This is the original dwarf planet, Pluto. This not-quite planet is the reason that dwarf planets exist. The internationally recognised classification was invented because of Pluto's demotion. When I was in primary school, Pluto was the 9th planet from the Sun, the porcupines in the planetary mnemonic. But that planet is no more. Now Pluto runs its own league. It is the leader of the dwarf planets. And it is awesome. We've seen it in stunning detail, revealing its brilliant heart with a rich story. But I don't want to talk about Pluto today. Instead, I want to talk about Pluto's cousins, the other not-quite planets of the solar system. These are worlds of their own, with their own stories to tell. So, let's take a look. We begin our journey not in the frozen outskirts of the solar system, but on our doorstep. This is the asteroid belt, home to rocky pebbles and boulders, but also to Ceres. Ceres is not an asteroid. It is big. So big that it's round, like a planet. And it probably has a rocky core, like a planet. And a mantle, like a planet. Just like Pluto, we've visited Ceres, this time with the Dawn spacecraft. From a distance, it looks not unlike our moon, cratered and greyish. But in false colour, you see a lot more, like this bright white patch at Akata crater. This is Cerealia facula, a salty residue made from the same stuff as washing soda and ammonium chloride. It's believed to have come from a slushy brine beneath the crust of Ceres, and those depths are important. That mantle of Ceres I mentioned earlier is believed to be made from water ice, potentially making up to 1/4 of the dwarf planet's mass. As such, it's an interesting candidate in the search for extraterrestrial life. Now, let's zoom past the planets and Pluto into the heart of the Kuiper belt. This region, in the far corners of the solar system, is home to hundreds of thousands of icy bodies smaller than the Moon. Within that belt is Haumea. Roughly the size of Pluto, Haumea is one of the fastest spinning objects in the solar system. It completes its rotation every 4 hours, squishing it like a football. It has 2 moons, Namaka and Hayaka, and a small ring system. We've only seen it from Earth, meaning we have to rely on CGI and visualizations like these to see it in detail. Let's head further out now to Makemake, 45 times further from the Sun than the Earth. We know precious little about Makemake, other than its size, about 715 kilometers. Its day is 22.5 hours long, comparable to Earth's, and its surface is believed to be a reddish-brown colour, not unlike Pluto. That surface also likely contains pellets of frozen methane. The last confirmed dwarf planet is billions of kilometres further out. With a year spanning 557 Earth years, Eris could be considered Pluto's archenemy. At 1160 kilometres across, Eris is just a smidge larger than Pluto. Its discovery in 2005 was the catalyst for Pluto to lose its planet status. Its surface is a frigid -231 degrees Celsius, with an atmosphere that thaws and refreezes as it moves along its orbit. These are the 5 official dwarf planets, but there are other candidates. I want to take a moment to discuss my favourite dwarf planet to be Sedna. Sedna is shrouded in mystery, orbiting up to 75 billion kilometres from the Sun, taking perhaps 11,000 Earth years to orbit once. It may skim the inner edge of the Oort cloud, a spherical shell of icy comets that effectively mark the end of the solar system as we know it. So there you have it. These are the dwarf planets of the solar system. The stories they can tell are the stories of our home. They are members of our stellar family and deserve to be recognised that way.